So welcome. So now we discuss fiber optic sensor. Optical sensor is a transducer which converts any form of signal into optical signal in the measurable form. So here optical fibers are used guiding media and hence called as a waveguide. So the basic black diagram. Optical source, modulation zone, and optical detector. So the optical source used here LED or laser. The optical signals produced with optical source and is transmitted through the transmitting fiber to the modulation zone. So the optical signals are modulated based on any one of these properties, is optical intensity, phase, polarization, wavelength, and spectral distribution. These modulated signals with any one of these properties are received by the receiving fiber in and is sent to the optical detector. So types of sensor: intrinsic sensor and extrinsic sensor. So extrinsic sensor means passive sensor, intrinsic sensor means active sensor. So the intrinsic sensor, active sensor, the physical parameter to be the sense directly acts in the fiber itself to produce the changes in the transmissions characteristics. For example, pressure sensor, phase and polarization sensor, and liquid level sensor. Extrinsic sensor or passive sensor is the extrinsic sensor. Separate in sensing element will be used, and the fiber will act as a guiding media to the sensor. For example, displacement sensor and laser Doppler sensor. And applications of fiber optic sensor is the optical fiber sensor has a wide range of applications in the measurement of various parameters such as temperature, pressure, flow rate, liquid level, current, etc. For example, cryoscope is used to measure the number of rotations of the fiber coil. Fluorooptic temperature sensors are employed to measure the temperature accurately. The pressure can be accurately measured using the photoelastic pressure sensor. So, though there are many applications of optical fiber as a sensor, let us confine the discussion the applications of optical fiber. One intrinsic sensor, pressure sensor, or one extrinsic sensor, displacement sensor. And so now discuss pressure sensor, phase and polarization sensor. That means intrinsic. See the diagram. See the black diagram. It is based on the principle of interference between the beams emerging out from the reference fiber and the fiber kept in the measuring environment. It consists of a laser source to emit light. A beam splitter made up of a glass plate is inclined to an angle of 45 degree. So with respect to the direction of the laser beam, two fibers wise reference fiber, test fiber. So reference fiber which is isolated from the environment and test fiber kept in the environment to be sensed are placed in the unit figure. So separate lens systems are provided in the split into the collect the beam. So a monochromatic source light is emitted from the laser source. The beam splitter kept at 45 degree angle inclined in the divides in the beam emerging from the laser source into the beams. So main beam and splitter beam are exactly right angles to each other. The main beam passes through the L1 and it's focused on to the reference fiber which is isolated from the environment to be the sensed. The beam after passing through the reference fiber falls on the lens L2. The splitted beam passes through the lens L3 and focused on that test fiber kept in the environment to be sensed. So the splitted beam after passing through the test fiber is made to fall on their L2. So therefore the changes in the pressure or temperature can be accurately measured with the help of the interference pattern obtained. Thank you. We discuss in next session.